Hey guys, my name is Trevor Simon, and I'm back for my security AI surveillance camera. I have tried to implement in more stuff like a data set. Uh, I'm using the humans data set from Cargo. You can go and check it out. So, what are we doing today? My introduction, I'm talking about my AI surveillance camera, whereby it's going to be detecting objects in motion, detecting faces. Basically, we are designing it for detecting only human faces. So if you appear in the camera, it draws a rectangular box around you and it's able to detect your face. I know that this is Trevor, this is Simon, this is this. So uh, I designed a heat map for it, and it's an object in motion heat map, whereby when you're moving, it can draw heat maps around you as a human being. But taking out, I implemented in some libraries that can take out what uh, that can remove other objects. Yeah, like cleaning up the camera so that it can only draw heat maps around the human beings. Yeah, so that's all about my heat map. Uh, so a correlation matrix, I used one, but I don't think that I need it because I think it's quite impossible to have a correlation matrix for an image data set. I'm using an image data set. I don't think I can plot images on the graph. Same to the box plots, because box plots are what I used to show distributions of numerical data values, especially when you want to compare them with between multiple groups. Meaning that if we have numerical data values that are split, then we have created clusters. These clusters need to be what compared. So we use box plots, whereby I don't think that for object detection we can have a box plot. Same as I have a lot of stuff that cannot implement online. Yeah, according to my research, I think a feature independence. We have feature dependence plots, and these ones are what are dependent on on each other. But I think future independence can be taken to be a partial dependence plots. So partial dependence plots mm, what are used as a tool for gaining insights into relationship between the features and predictions. Suppose you have a data set, and that data set has various features, like it has temperature, it has how can I say it? It has temperature, mm, it has the human being's temperature, it has the surroundings temperature. Those are all features of a data set. But mine, I'm only determining the image. I'm just determining images, like I'm looking at specific images. You get comparing this image, comparing myself to the what? To the to my data sets. So outlier plots I looked at when when I have box plots, then illustration on trends and time space. This happens when we use there is a visualization in Python that is called time space cube. And this time space cube is the one that is plotted on our trends. Okay, we use our data from the data set so that we can know the trends of how our model is performing. But I think, according to me, I cannot do that in my data set. But for you people with numerical data, yeah, I should advise you that you should have these plots. because they are really needed. They're really useful. So we go to cleaning and exploring our data set. So cleaning and exploring our data set, an image, I try to design some model to clean it up. I use various sources to know how to clean up a data set using that. And it mostly looks at cleaning up duplicates. Suppose we have negative images. Let me say we have positive and negative images. Negative images, we can look at them to be images that don't have faces on them. And let me say images in color black, images plain color black, such a thing. These images cannot work for us in the data set. So they are duplicates. Let me say black, 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 red, red, red. So we have to clean it. We have to clean them up. But I found it quite hard for me to clean up images that have the same name. Like different images, but with the same name. I think those are also duplicates. So according to other sources, they are talking about we can remove these duplicate images manually, clean it up so that our data set, so that we can increase the accuracy of our data set. But it's quite a hard thing to clean it up manually. Very hard. Because you have 60,000 images, you're going to look at all images and then you delete. Yeah, you can start today and you can finish tomorrow, which is the rest of your side. Then I designed the model that can train, test, and what? We can train it, we can test, we can validate. Yeah, I split I first created the folders. Then after creating the folders, then I imported the images using the OS module. Then I used also the Shootil. I imported Shootil so that you can copy my images from the original folder, which is my dataset, to the train folder and also the test folder. Yeah, it's the same algorithm, just changing words. Yeah. Though I found it hard for me to, it was giving me an error that OS import OS module is non-defined. So I was surprised about that, and I'm trying to fix that. So anyone who can help me, you can come up and help me out of that. Through my notebook. I have this code in my notebook. Fitting, I think fitting anyone initial model of my choice. I chose a anti-eye surveillance camera, obviously. And this is all about object detection in motion. So I trained my model using the splitted data sets and validated and tested it so I can recognize the specific person so that it can give the images, it compares the images and gives the matching name. So I use the function called face names to determine whether the face in the video is known. Then it will display the name on the image. Whereas if not, it will display unknown. In my view, I would include that using these functions, I'm defining the architecture of the module. And remember that talking about the architecture of the module, I'm looking at increasing the accuracy of the module. Yeah, the accuracy of the module. Then I'm looking at many things. I'm looking at tuning my hyperparameters. I think I've tuned my hyperparameters from there using these functions. Thank you for listening. Have a nice time.